In this video, we'll be covering compound interest. Specifically compound interest that is either A, based on this formula here, compounded monthly, daily, yearly, weekly, anything other than continuously, or, again, based on this equation, compounded continuously. Now, in both of these equations, you'll notice variables P, the initial amount invested, R, the rate at which it's being invested, again, the interest rate, or T, the time in years. You'll notice this equation up here where it's compounded in any other moment other than continuously, it has an n variable in there. Well, that n is nothing more than the number of times it's compounded in 1 year. Now, the difference between this exponential equation and other exponential equations is that this one particularly must be used such that t is in terms of years. Again, all other exponential equations, t could be days, months, weeks, but in this particular example, when we're compound interest, t must be in terms of years. So, the first equation, or first question, it says find the balance of $1,000 if $1,000 is invested at an annual interest rate of 10% for 2 years, compounded, first case, monthly. So the fact that we're compounded at something other than continuously, I will be using this formula right here, where the amount that I'm investing is $1,000. My rate is 10%. Now, if R correlates to 10%, it's not actually 10%. R is actually going to be equal to the decimal representation. Now, the way I want you to think about percentages is that they are a unit of measurement. It is 10 out of 100, which means that if I have 10 out of 100 or 10 over 100, that's the same thing as 1/10. Okay, so in this case right here, this is my R value, so that's going to go right inside the value for R. N, you're looking at monthly. Well, if this is compounded monthly, how many times would we compound it in 1 year if we compounded it once a month? In that case, N is 12, again, because it's 1 per month. And there are 12 months in a year. So, in that case, my N is 12, and I'll have a 12 up here as well, times, and T. The number of years that we're compounding it for is 2. In that case, I'm going to have this equation right here, A equals this thing, and all I have to do is type that thing into a calculator. Okay? The setup for the next one is, what if I'm compounding it daily? So this is part A. Part B, compounding it daily, we will note that N is 365. Yes, technically there's 365 and a quarter and modifications of other values, but this is the number of times we're going to compound it if we're saying we're compounding it daily. Notice in this question, nothing else changes. The amount we're investing is still 1,000. The rate at which we're investing it is 10%. We are compounding it, again, instead of 12 times, 365 times. So this value N is 365. And then I'm going to have an exponent of 365 times over 2 years. Okay? And lastly, C. C is the question if we compound it continuously, in which case I'm going to use this formula instead, PE to the RT. Now keep in mind, this particular formula right here is A equals P, the base is E, to the power of R times T. So those two pieces, the R and the T, are both powers. You'll also note that this P is a multiplication by E, so it has nothing to do with the exponential right here. Okay. Now if I'm asking you to compound this information continuously, once again, my P value is 1,000. My R value is still 0.1, and my T value is still 2 years. In which case, again, one more time, we're going to type all three of these things into a calculator just as we see them very, very carefully, with a decimal point here, here, and here, and that will provide us with approximately values of what we should be getting.